hydrocarbon parent chains that have what we call branches. And these branches are shorter hydrocarbon chains, alkyl groups that are attached somewhere to the interior of the parent chain. So, quick reminder here is that if we have a carbon chain, and I'm just going to, here's carbon, and we'll say it ends there. So the carbon that is either to the most right or to the most left in the chain, so this is where the chain ends. So this would be considered a terminal carbon. And so alkyl groups, these branches, can never be on a terminal carbon. They need to be somewhere in the interior, sandwiched between the beginning and the end. Okay, so let's just take a look. So your first job, in order to come up with the best name for the organic structure, is to first identify the parent chain. And the parent chain is the longest carbon to carbon chain. And when we go to circle it, we can cross over. So notice when I'm circling, I'm crossing over carbon to hydrogen bonds, but I'm not going through any of these carbon to carbon bonds. So when you take a look, I cross through all these carbon to hydrogen bonds, but then right here, I cross through a carbon to carbon bond. So these carbons in the yellow, they represent what we would refer to as the parent chain, and this parent chain is N equals 4. So when we go to table P, where N equals 4, we know that we use the prefix but. Now, when you take a look at the bonds that are inside the carbon to carbons, all of these bonds are single bonds, so we understand that we use the ending butane. So we have an alkane, so we have a butane. But we notice in this process that there was a carbon to carbon bond that was cut through. So any carbon chains that were left outside of the parent chain circle, I'm going to box this. So that would be like this right here. This is a branch. Now, we still use table P. So the branch always has to be smaller than the PC. So the branch has to be smaller than the parent chain. That's not an option. So if you think about a tree, the parent chain is the trunk, the massive part, and the branches hang off of the trunk. So take a look. So for this branch, N equals 1. So that means that this branch uses a prefix of meth, but the branches have that slightly different ending. So we have our branch length, and it ends with YL. And notice that this part, the branch, comes before the parent chain. So this is our parent chain information. So I would put the one carbon branch before butane. So this branch would be methyl. Now, what we have to determine, so with this one, this is the only possibility location for this particular branch. So let's take a look at the next example. So this next example, I'm going to circle the longest carbon to carbon parent chain. So here's my parent chain, and when I take a look at this parent chain, N equals 8. So a prefix of 8 uses oct, and all of the bonds within that carbon chain are single, so this would be known as octane. But when we take a look at this, I notice here there is a carbon hanging off that's not part of the parent chain, so this is where N equals 1. So I know that this is a methyl. And as I keep looking across, I notice that there's another carbon that's not part of the parent chain. It's on a different location, and its N number is also 1. So this would be another methyl. So I could put out methyl methyl, but we have learned before that when we have two things of the same type, we can shorten the name by, instead of saying methyl methyl, we can say dimethyl octane. But what we need to do is figure out where are they in the structure. So we have to go back and do our location numbering. So we have to first do the numbering left to right. So 1, 2, 3, 4, 5, 6, 7, 8. So the red boxed one is on carbon 3 left to right, and the blue boxed one is on carbon 5. We need to do the numbering back right to the left to figure out what is the best location designation numbers. So when we go right back to the left, the blue one is on carbon 4 and the red one is on carbon 6. So we go with the lowest combination, and in this case the lower combination 3,5 is better or lower than 4,6. So these are the numbers we put out front. So we have 3,5 dimethyl octane. So let's take a look at this next example. So when we take a look at it, we circle this parent chain. Okay, and when we circle this parent chain, so that's our parent chain, N equals 8, and we notice that within that parent chain all the bonds are single, so we know that this is octane. And when you look across this, so when I look across the top, I notice that there's a carbon up above that is not part of the yellow circled parent chain. So this is an example of a branch. And in this branch, the number of carbons that I boxed in, N equals 1. So that is a methyl branch. But when I'm taking a look, once again, I notice down at the bottom, there is another carbon hanging off of the parent chain. It's not directly connected to the one that's boxed in the red color. So this is a different branch. And this branch, N also equals 1. So it is also a methyl branch. So instead of saying methyl methyl octane, we condense this down to dimethyl. And this is a pretty long parent chain, so we need some number designations. So we need to go through that whole process again. So you have to first take a look and number left to right. Number your carbons. So the red boxed in one is on carbon 3, and the blue boxed in is also on carbon 3. But you also have to look at it get used to looking at it in the opposite direction and renumber right back to the left. And right back to the left, the red one is now on carbon 6, and the blue one is also on carbon 6. So these two branches are on the same carbon. We have a dimethyl, so that means we need two locations. So do we use 3,3 or 6,6? We choose to use the 3,3 because that is a lower number designation than 6,6. So we have to put this out front. 3, 3 hyphen dimethyl octane. Now, when I take a look at this next example, it's not a full-blown structure, but there are some definite clues that are given to me here. So when I take a look at this, notice that I have a carbon with its hydrogens in parentheses right here, and I have a second one right here. In the condensed formula, this is a huge clue that these guys are branches. So this is a branch and this is a branch. So these are examples of branches. The carbons not in the parentheses, these are the parent chain carbons. So I underline them in blue. So when I take a look, 1, 2, 3, 4, 5, 6. So this would be hex. Okay. And I'm going to use some clues here. So when I take a look at this carbon here, the carbon, is attached to this carbon. So this carbon right here has one bond from this carbon. It has one bond from the carbon that's a branch. It has one bond from the carbon that's next in the parent chain, and it gets its final bond from this carbon, from this hydrogen here. So this carbon has 4 single bonds. This next carbon that has a branch attached to it, it gets one bond from the previous parent chain carbon. It gets a second bond from the next carbon in the parent chain. It gets a bond from the first carbon in the branch sequence, and it gets its fourth and final bond from the hydrogen that's directly attached to it. So this carbon here is attached to this guy. So this carbon also has 4 single bonds. So that's my clue that this is definitely part of the alkane family. So this is hexane. Okay, so now take a look. What is in parentheses here? Okay, so for this branch here, N equals 1. So that means that this is a methyl branch. Where this next branch, there are 2 carbons in the parentheses, so N equals 2. So that means that this branch uses the prefix eth, and because it's a branch, it's YL. So I don't have a methyl branch here, okay? I have 2 branches of different sizes. So I have a methyl and an ethyl. So when I go up here and look at the rules, okay, if more than one branch and they are different sizes, put them in alpha order. Well, alphabetically, E comes before M. So in the name, I would put ethyl first, followed by methyl. So I have an ethyl branch and a methyl. Can't condense this down to di because they are different sized branches. Now we need to do numbering. So we have to figure out their locations. So still do it left to right, but only number the carbons I underlined in blue. So carbon 1, 2, 3, 4, 5, 6. So the yellow one is on carbon 2 left to right, and the orange one is on carbon 3. Well, we have to get used to looking at it in the opposite direction just to double check ourselves. So we renumber right back to the left. And when we go right back to the left, that's 1, 2, 3, the orange one is on carbon 4 and the yellow one is on carbon 5. So here's the thing. 2, 3 is the better set. So the first one I come to is methyl, and the next one I come to is the ethyl. So I have to make sure I match those up correctly in the name. So I have a 3-ethyl, 2-methyl hexane.